Hello, welcome, and today we're going to talk about initial value problem uh, with the introduction. So, what are we gonna do? Verify if the given solution is a solution to the differential equation, and if it is solution, then we will find the particular solution. So let's get started. Well, recall that we already know how to verify if solution, if a general solution is solution to a differential equation. So again, the same concept. So this is the highest derivative, y prime. So we have y prime must be 4 times c e to the 4x. Okay. And we substitute y prime here and also y here. So we have 4 times c e to the 4x is equal to 5c to the 4x. So is this true? Is this a solution? No, this is not the same. So that means this is not a solution. If it's not a solution, then this doesn't matter. The particles, I mean, the initial value doesn't matter. So we can skip this. Okay. Next, y prime plus y equals to x and y and general solution y equals to c e to the negative x plus x minus 1 and y initial equals to 2. Okay, and we see here this is just a first order differential equation. So we just have to have y prime equals to negative c to the negative x plus 1. Derivative of constant is just 0. And we substitute it, we have negative c e to the negative x plus 1 plus y c e to the negative x plus x plus minus 1. Okay, and that's it equals to x. So we have this cancels, 1 and negative 1 cancels, and x is equal to x. So this is true. So this is a solution, a general solution to this differential equation. Remember that this is a family of curves. So this is a solution. And we're giving an initial value is equal to 2. So this is talking about given a point, like we're given a point 0 comma 2, and on that point what is the particular solution. So if we substitute this and find c, and we will find the particular solution at this given point. So we substitute y sub 0. So this is technically just y of x. Y of x equals to c times e to the negative x plus x minus 1. And 0 is as x. We just substitute 0. So y of 0 is equals to c e to the negative 0 plus 0 minus 1. Well, y of 0 is just 2. So 2 equals to c e to the negative 0 plus 0 minus 1. And we know that this is just 1 over e to the 0, which is just 1. So we have c plus 0 minus 1 is equals to 2. And we have c equals to 3. We we plus both sides by 1, right? Okay, we have c equals to 3. So the particular solution, y particular, is 3 e to the negative x plus x minus 1. So this is the solution at this point, this initial value. Okay. Next, we have y prime minus y equals to x e to the x with the proposed solution y equals to c plus x squared over 2 times e to the x y initial equals to 1. Okay, so we have again a first order y prime is equals to we have a product rule, so we need to have c plus x squared over 2 times the derivative of e to the x, which is e to the x, and then plus by um the derivative of the inside this one, which is c plus 2x. Well, we have c plus x squared by 2 e to the x plus 0 0 here 0, and then derivative of this, which is just 2x by 2. Okay, this is false. Sorry about that. 2x over 2, we have times e to the x. Okay, and we distribute this, we have c e to the x plus x squared over 2 e to the x. Okay, wait, let me check this again if it's true. 2x, yep, over 2, and we have plus cancel, we have x e to the x. Okay, and we have x e to the x, so this is just the y prime, and we substitute to the differential equation. We have c e to the x plus x squared over 2 e to the x plus x e to the x minus by y. Our y is just c e to the x when you distribute this, and plus by e to the x, e to the x, x squared by 2, that equals to x e to the x, and we can cancel things out. Well, minus c y equals to this one, right? So this is brackets here, and this one cancel with this one. Yep, c e to the x minus c e to the x, and this one a half. Yep, this one cancel with this one, and we are left with x e to the x is equals to x e to the x, which is true. And so this is a solution to this differential equation. So we have to do this y of 0. So y of 0 is equals to c plus 0 over 2. Okay, y of 0 is just 1. So 1 equals to c. And substitute this to the general solution, or this is just a family of curves. We have y is equals to c, which is just 1 plus x squared over 2 e to the x. So this is the solution at the point as 0 comma 2. This is y part particular. So this is the solution. I should leave it like this. And okay, next we have y double prime plus y equals to cosine x. Y given proposed solution y equals to c1 cosine x, c2 cosine x plus a half x sine x with we have y of 0 is equal to 0 and y prime 0 equals to 0. C, we have second order, so we have to go to the second derivative y prime equals to c1. What's the derivative of cosine? The derivative of cosine is just negative sine, so negative c1 sine of x and plus c2 times the derivative of sine x is cosine x. So c2 cosine of x plus by a half. We need to use the product rule here. And we have x times cosine of x plus by the derivative of the first, which is 1 times sine of x. And we need to do another derivative. Y double prime is equals to the derivative of negative sine of x is just negative c1 cosine of x and plus by c2 or cosine of x. The derivative of cosine of x is negative sine, so negative c2 sine of x plus by a half times the derivative of this one, and we need to use another product rule. So x times negative x sine of x and plus by 1 times cosine of x, and this one is plus by the derivative of sine of x, which is just cosine of x. Okay, let me check if this is true. So we have x times the derivative of cosine of x, negative sine of x, plus by our derivative of the x as 1, and then times by cosine of x. Okay, and we have negative c1 cosine of x minus c2 sine of x plus by let's see if we can, oh, we cannot cancel the term, so we are left with a half times negative x sine of x plus by cosine of x and plus by a half sine of x, sorry, sine of x. Oh, and okay, and we have to substitute this to the equation. We have differential equation. We have negative c1 cosine. Wait, let us substitute cosine as tau and sine as alpha. So c1 tau. That's zeta. Wait, tau minus by c2 alpha and plus by a half minus x alpha plus tau plus a half alpha. Okay, and we have minus or plus by y. Y is c1 tau and plus by, let's say that, c1 tau and plus c2 alpha and plus by a half x alpha. And let's see what does this equals to cosine of alpha x, or you can say tau. Does it equals to tau? Okay, let's just leave it as this. And we can see here, can we cancel things out? Plus C1. Oh, look, we can cancel this one. And this one, C2, this one. And oh, look, we can cancel this. If we distribute a half, we have this one cancels with this one, and a half of, and we just have a half tau plus a half alpha. That's equals to tau. And this that's the so a half cosine of x plus a half sine of x does not equals to cosine of x. So this is not a solution. So this is not a solution to this differential equation. Um, it's not. Wait, let me check. So we have negative zero and then a half plus a half alpha. You have a half alpha and then z and then a half x and well, this checks out. So there's no this is not a solution to this differential equation. Okay, and let's try this one. We have y prime equals to y ln x. I mean ln y equals to e to the c e to the x. Y of 0 equals to e. So this is just first order. So we have c e to the x, e to the c, e to the x, and substituted we have c e to the x, e to the c e to the x. Okay, is equals to e to the c e to the x. Ln of e to the c e to the x is just ln of c e to the x. C e to the x. And does that equal? So we have, wait, sorry, my bad. We have c e to the x, and this does equal. So this is a solution to this different solution. So we can do the particular solution, and is y particular equals to, wait, y of 0 is equals to e to the c e to the 0. Well, we have e to the equals to e to the c times 1, and take ln both sides. We have c is equals to 1. Okay, so we can substitute it into the general solution. Y is equals to e to the 1, e to the x. So this is just, this is the particular solution at the point 0 comma e. And next we have xy prime plus y equals to 3x squared, y equals to c over x plus x squared, and y of 1 is equals to 2. And we have first order, so we have y prime equals to negative. This is negative. The derivative of this is negative c over x squared. Okay, and plus by 2x, substitute this x times by negative c over x squared plus 2x plus by ly c over x plus x squared and equals to 3x squared. And we can distribute x here. We have negative c over x plus 2x squared plus c over x plus x squared. Does it equal to 3x squared? Yep, it does. Just cancel out. Combine this, we have 3x squared. So this is a solution. And y of 1 is equals to 2. So we have to find the particular solution at this point. Yeah, the general solution at this point. And if y of 0, y is of 1. y of 1 y of 1 is equals to c over 1 plus 1 squared. And y of 1 is just 2. 2 equals to c plus 1. And c equals to 1. Okay? Substitute this back to the general solution. We have y equals to c over 1. Oh, sorry. Substituting c. So we have 1 over x plus x squared. Okay, this is the solution of the general solution at the point 1 comma 2. Okay. Next. Okay, our final question. Of y double prime minus 4y prime plus 4y equals to 0 and y equals to c1 e to the x plus c2 x e to the x. Y of 0 equals to 1 and y prime of 0 equals to 1. And you can see this second order. So if y prime equals to c1 times 2e to the x plus by c2 times this guy x plus e to the x, which is just x times 2e to the 2x plus by e to the 2x, and y double prime equals to 2c1 times 2e to the x plus c2, okay, times by this. We need to take another derivative, so we have 2x times 2e to the 2x plus by, forget close another close bracket, plus by our derivative here x2 e to the 2x plus by e to the 2x. Okay, close bracket. And so we can actually simplify this. I think we have 4c1 e to the 2x plus c2 times, we can combine this and this. We have 4x e to the 2x plus 3e to the 2x. Okay, and substituting it to here, we have 4c1 e to the 2x plus c2 4x e to the 2x plus 3e to the 2x, and then minus 4 times y prime. What's y prime? That's this one. We have 2c1 e to the 2x plus c2 x times 2e to the 2x plus e to the 2x. Okay, and wait, let's just simplify this first. Minus 4 2c 2c1 e to the 2x plus c2. So we have 2x c2 c2 e to the 2x plus c2 e to the 2x. Okay. Um, this is close. And can we cancel it with one of these C2, C1, C2? What's this? What? Y double prime, right? So C2, 4. Yeah, 4x e to the 2x. So of C2, y, y prime is just this, right? Y prime is 3. C2 times, wait, C2 times by 2x. Oh, this one. What is, sorry, sorry, my bad. I'm tweaking. X to x, e to the 2x plus e to the 2x, and f. Okay, this should be correct. Wait, correct me in the comments if I'm wrong. Wait, 4x. Okay, let's continue. C1 e to the 2x plus C2 4. Yeah, this is 4, right? 4. Yeah, this is 4. C2 4x e to the 2x plus 3e to the 2x. And well, actually, this can cancel out. Wait, no, it can't, because this is not. Yeah, this is if you x times 2. Yeah. Okay. Um. So we just have this, and we have plus by 4 times y, c1 e to the 2x plus c2x e to the 2x. Well, I think we can cancel out something now. Plus by this one. Ah, yes, this one. If you distribute 4 and distribute the 4 here, this is negative, and plus this one. So this one cancel with this one. If C1, okay, let us see the new equation. 2x plus C2, 4x e to the 2x plus 3e to the 2x minus by, this is 2 times C1, right? Minus 4y prime. Yep, 4 times 8c1 e to the 2x. Okay. Plus by negative 8x c2 e to the 2x, and we have plus by 4 times c1 e to the 2x, and thus that equals to 0. We have minus c2 plus 4 for c1. Well, for c1, this one can combine and then cancel with this, and then c2 for 3x, c2 minus 8. This is minus 8, and y double prime here, this is 4, and then we have c2 times 2x4. So we have, yep, it's just c2, and this is c2 minus 8. This is plus 3 e to the from here, so there's no c2 here, right? There's no c2. Oh, wait, there is c2, because when you distribute this, you'll have c2. So 5. So this is 3 times minus, wait, this is c2, so y double prime. This is y double prime. Yeah, this is, but it doesn't change things. This is still not equals to zero. Oh, wait, please correct me if I'm wrong in the comments, please. So we have c2 8c2 x e to the 2x minus 8x c2 5. Wait, oh my. Okay, this is 7c2 x e to the x minus 8x c2 e to the x 2x, and this is just negative. Yep, this negative c2 x e to the 2x, which is does not equal to 0. So this is not a solution to this difference equation. I'm gonna rework this tomorrow because this is already nighttime, and I'm very sleepy, so I'll check this tomorrow, and I'll let you know in the comments